everybody continue to be at rest or to move with uniform velocity unless acted upon by a resultant force. An object at rest tends to stay at rest unless acted upon by an external force. Also, an object in motion tends to stay in motion unless acted upon by an external force. But this second part of the motion of the law is kind of against what we are used to in our everyday activities, because everything that requires motion, we need constant velocity, we need constant force to move. Example, like if you are pushing a wheelbarrow, for the wheelbarrow to continue moving, you need the constant application of force for it to keep moving. Same thing for your car. Your car needs the engine, which is through the combustion, we keep the car moving. Immediately you remove your leg from the pedal, from the accelerating pedal, the car will stop or will come to a state of rest. So, being that everything that we are used to require continued application of force for there to be motion, where did Newton get this law that any object in motion tends to stay in motion unless an external force acts upon it, whereby every object that needs motion in our earthly atmosphere needs the constant application of force? Okay, for us to answer that question, we know that in our Earth's atmosphere, there's a lot of force that acts against every object in motion. Example, wind resistance. Another example, we have friction, and we also have gravity. So these are the kind of forces that will prevent objects in motion to be in motion, to continue to be in motion, because all this force will act against it. So let's take space, for example, where there's nothing, like empty in space. If imagine a rocket, if you launch a rocket, for it to break free from the Earth atmosphere, you use some fuel, then the rocket will launch. But immediately the rocket gets to space, the rocket will turn off its engine. The amount of velocity that the rocket use to get to that space, that will be the constant speed the rocket will be going, even when the engine is switched off, when the engine is not working again. So in space, where there's no wind resistance, when there's no friction, there's no gravity to pull it down, at the speed the rocket is going before it gets to space. Imagine maybe when the rocket leaves the Earth, it leaves the Earth with, like, let's just say 13,000 miles per hour. With that same speed, the rocket gets to, maybe by the time the rocket will get to space, it's around 15,000 miles per hour. And then when it gets to space, the rocket turns off its engine. When the rocket turns off its engine, you will expect the rocket to come to stop, as we are experiencing on Earth here. But in space, since there's no force to act against it, the rocket will continue to be in motion and will continue to move at that speed of 15,000 miles per hour, since there's no force to act against it. So this is what Newton is saying, that objects in motion will stay in motion with uniform velocity, with that same velocity, unless a force acts upon it. Then objects in motion will stay in motion unless an external force acts upon it, or an umbrella force. That is, for example, with this pen here, it's at rest. It will stay at rest unless an outside force acts upon it, then it will move. That is what the capacity of an object to resist change in motion is called inertia. That is why the first law is called the law of inertia, because objects in motion will tend to stay in motion unless an external force acts upon it, they will always want to be in motion. Force must be required to initiate or terminate a motion. That is, for there to be motion, we need force to be motion. Even when there's a motion going, for it to come to an end, it will need another force to stop it. So that's what we are saying. And then, in the absence of force, constant velocity is maintained. As I've said, the rocket will accelerate a little while, then when it gets to space, it will turn off the engine and continue to move at that constant velocity. It will continue to move. For the velocity to increase, force need to be applied, maybe through the engine, and then for it to come to an end or to turn from side or left to right, there's the need of force to be applied. So in the absence of force, constant velocity is maintained. And then also another quick notice is that more mass is equal to more inertia. That is, a object that is much heavy will require a very big force to move. So thanks for watching this video. You can put in the comments your any contribution or any question that you want to ask. You can put it there.